to the next session at GOTO Conferences in Amsterdam. It is my pleasure to be your room host today. We have Matt Turner with us, who is a software engineer at Tetrate. He's also an expert with containers and orchestration. Apologies if I mispronounce something, but with infrastructure as code, Kubernetes, CI/CD, all of that stuff, a lot of things which I don't understand, but it's fun to discuss anyway. So while this is an AMA, so I will be taking questions from the audience as well as a few that I wonder myself. Hi, Matt. Welcome to the session.
Thanks for having me.
I hope you're having a lovely time so far at Amsterdam in our GOTO.
Yeah, Amsterdam's always a great city to visit, and yeah, GOTO's been really good. I've been to so many sessions this time. They've all been awesome.
Yeah.
Some of the other speakers in the audience, which is very flattering.
Yes, exactly.
Done great sessions themselves. So.
And experts themselves,
absolutely.
As well. And I think there's been a lot of sessions on a lot of topics. It's quite wide in that way. There's some bit on Kubernetes, there's some bit on AI, there's some bit on platform engineering and all sorts of things. And I know you're an expert in service mesh, but do you think it's still relevant in 2023?
That's an interesting question. Yeah, because that's this is a general software engineering conference. There's a lot of Java and whatever being talked about. A lot of folks are talking about AI. There are still a few of us, I think, talking about infrastructure. And yeah, so the service mesh is like a niche within a niche. I think it's more relevant. I think you hear less talk about it because it's not new anymore. It's not that blip on the ThoughtWorks radar. It's not sort of, early adopter stuff on the curve. I think it's like early majority now. And I think it is still waiting to cross the chasm. I think it's still waiting for everybody to use one. But I did see statistics. Sysdig, I think, one of the security scanning folks who had like massive data across like all Kubernetes clusters, released some data showing like the top images they're running. So like 25%, I think, of all clusters have like an Nginx in them. And I think they saw Istio in, I want to say 15% of clusters, or maybe that was 25. It was a lot anyway. It was more than I thought. So I think there's a lot of folks silently using it, and there's maybe not so much hype, which is maybe why you don't see the talks about it. But I think it's even more relevant because there's now all of this regulation coming in. I mean, not just folks who are in high compliance, like high assurance environments, but just in the States, the White House just saying, thou shalt do zero trust, right, whoever you are. I mean, anybody who interacts with the US federal government has to be on the FedRAMP program, FedRAMP compliant, and that has a bunch of controls in it. But even if you're not subject to any of that, like there's so much talk about sort of zero trust and those kind of security postures. And I think, sidecars, the service mesh, are really the only way to do that. So I think that it's more relevant than ever with folks looking to do proper zero trust, like, day two Kubernetes stuff. Okay, I've got Kubernetes, how do I now make it more secure than I was before? Let's actually get the benefits of this platform. So I think that's where service mesh comes in.
Do you think people, companies who are more concerned about compliance and security, those were the ones who will be, implementing service meshes before, or is it just something that companies should anyway do it?
I mean, I personally think almost everybody should do it, but there's the sort of four main selling points, right, of a service mesh. If you go to the website, there is the security aspect. I mean, I work at Tetrate. We help big, larger enterprises, government organizations, mostly with service mesh, and almost all of our interest comes through the security aspect because they have to have it if they need to be compliant with some regime. And there's always money. I mean, we're in a bit of a downturn, but security still always has money. So to be frank, there's that. But there's a lot of folks who still want the observability, which is the second pier, and the resiliency. So if you've lifted and shifted, you've moved to the cloud, or you've broken up your monoliths, and now you've got microservices. You just built a distributed system. You've got whole classes of problem you didn't have before with, network calls failing or whatever, and you want to get that resiliency back. Then you can use a Hystrix or a Jetty or something. But an easy way to do that is with a service mesh. And then the fourth sort of headline feature of a service mesh is the sort of service discovery, routing, and folks are using that for progressive delivery, right, and for A/B testing and all the good stuff, and just for making a more abstract and easier platform with like powerful service discovery features. But yeah, it's not just security. It's not just compliance. A lot of folks, they have to be compliant. Basically, the only way to be compliant with a lot of these programs, like anything in the States that involves the NIST standards, is service mesh. A lot of folks, even if they don't need to be compliant, they still want security. But I think there's still definitely users who are like, I lost a lot of observability when I put things in Kubernetes because I can't attach a debugger, and this namespace calling this namespace, it's not a function call anymore. I can't just attach a debugger and step through that call stack. It's now a network call. So it's much more likely to fail, and I just lost all the visibility of it. So you add a service mesh and you just get the trace bands for free, and I think a lot of folks are just really picking off that, I hate to say low-hanging fruit, but taking those easy wins from getting that kind of power.
So why do you think companies actually stopped using service mesh?
So, I mean, do you mean why not everybody's doing it?
Exactly, yes.
So I think there's quite a lot of, I think it's an advanced thing. I think if you look at it in a sort of tech stack kind of view, most people's view is that you need to go to the cloud, and then you need to maybe containerize, right? So you go to the cloud, you get some VMs, and then you containerize, running Docker locally, and then maybe you use ECS, and then maybe you move to Kubernetes, and they see it as, and obviously startups starting now, that's not the journey they've been on, but if you've been around since the 90s, maybe that's the journey you took. You see, a lot of folks thinking that like a service mesh is next after Kubernetes, and they feel they haven't completely nailed Kubernetes yet, or they don't want to take on the extra cognitive load. So I think a lot of people look at it and I don't think that's true, by the way. I think we've seen a lot of folks actually get a service mesh first and use it on their existing workloads on VMs, like get that observability, get an abstract sort of naming scheme, get the service discovery from it, and then move into clusters, because they know that's going to be probably quite a long process. Like realistically, you're going to be in this hybrid mode of VMs and Kubernetes for quite a long time, and the service mesh can bridge that gap. So if you actually put the service mesh in first. So anyway, but I think a lot of folks see it as like another tech step that they haven't taken yet. They worry about their cognitive load. They worry about the skills on the team. I do quite a lot of Istio training. There's still a lot of people out there who want to know that because they don't feel they have the skills yet. And then there is some FUD around the technology itself. There always was a lot of FUD around service meshes and Istio in particular. Some of it, honestly, 5 years ago was valid. I don't think it is anymore in terms of the ease of installation and upgrade and the reliability. And the resource usage, the whole resource usage FUD is still being thrown around.
Yeah, because budgets should not be an issue at all with this.
You think budget, and it doesn't use as many resources as people think, right? As people have been told, and especially and this is why so many people do it as a security play, right? Because security have got the money.
Yeah.
But you'd hope that it actually doesn't use that many more resources. And I mean, what's the statistic that Amazon show? Your average EC2 is 3% utilized or 5% utilized or something. So there's usually space in there anyway. Clusters are better. I mean, Kubernetes is orchestrated, does a much better job of bin packing, but they're still not, running at that magical 80%. So I think there's a lot of FUD, but it's, like Istio, for example, it's the biggest service mesh. It's been addressing that. You've now got ambient mode, which is another way of running it. You lose some of the security guarantees, like it's not applicable for some folks because you lose the security guarantees of having sidecars alongside every workload. But by sharing the proxies, you do get advantages in resource usage. So yeah, that's, it's starting to be addressed.
You spoke of progressive delivery. So what kind of strategies or techniques do you suggest or to use, for developers to use to ensure seamless container deployment and rollback?
I mean, this is kind of a pet topic of mine, I guess, because I built it once and it was really cool. And I think we're now at the point where we have the technology to do this. You don't have to manually go and build. When you saw this, some people were doing this 10 years ago, but it was always, if you look at your Wardley map, it was always like a custom build kind of project. I think now if you take basically Kubernetes, Istio, a GitOps operator like Argo CD or Weave Flux, and then Weave Flagger, I think the Argo project's got an equivalent of that now. You can get pretty automated, like progressive delivery stuff. So sorry, what was the actual question?
What strategies or techniques would you suggest for developers to use for seamless container deployment and rollback? When it comes to progressive delivery.
So I did a whole talk on this last time because I think it's quite complicated and there's a lot of stages. But I think the technology basically is out there. So if you get one of these progressive delivery operators, something like a flagger that will it's nothing you can't do by hand, but it'll automate. So the key point at the talk was separating deployment and release and saying that deployment, by my definition, is getting the workload running in the cluster, right? And you can and should do that continuously, right? As soon as something's built, run it, and run it in prod, so it's in a representative environment. But that's not the same as release, which is actually exposing it to the user, or exposing the user to it, depending on how you want to look at it, because that's what carries risk, right? Because it may be bad, it may give the wrong answers, it may be too slow. So you can get something in prod, and you can then, it can just sit there forever, right? And it won't do any damage, uses like a nominal amount of RAM maybe, and you can then hit it with tests. You can hit it with automated tests. You can use manual tests. If you've got something like a service mesh, like a clever SDN layer, you can set a header and have that route traffic to like this new version that's just sitting there. So you can do end-to-end tests, and you can do like black box tests, but in a representative environment, because staging is never going to be representative. If it's in prod, it's in prod. You have to be a bit careful of not letting it write to the prod database maybe, but there's ways around all of this stuff. So getting something running in prod and then doing all the testing you can, or the synthetic testing you can, that's continuous delivery. Then if you then separate release, and as I say, you get an operator like WeFlagger that'll say, right, I see you've put a label on this thing to say you've done all the testing you can, it's ready, I'm going to send it 1% of traffic, I'm going to look at its error rate and check whether it's in budget, check whether it's worse than the last release, I'm going to look at its latency, and as long as all these SLOs continue to be met, I'll continue to roll traffic out to it, because people do these sort of progressive deployments, they'll roll more and more pods out. You might have 10 replicas and you'll replace the pods. I would say don't do that. Just start rolling traffic out, and then you can roll traffic back, because it's that user experience and whether that user gets an error and a tiny response that matters, and just let the autoscaler take care of like how many of these things you're actually running.
So it also means the whole process there should be continuous testing throughout as well?
I think it's a really good opportunity, to do more continuous testing, because if you've got this new version, sat in prod, so connected to the correct database on the same network as the live version, you can just do end-to-end testing like you can do anywhere else. It's maybe a bit more representative, but you can start doing things like mirroring traffic. So every user request comes in, goes to both versions, and the response that's given is given from, the user always gets the response from the current stable version, but the new version also gets to give a response, and you can literally compare them, like diff them, right? And if this is an API end, but if the version bump is not actually meant to change the semantics of the thing, it's just meant to be a bug fix, or even if it is meant to be, add a new feature, add a new API endpoint, you certainly want to check the diffs on all the old API endpoints, or the old RPC methods are the same. So I think it gives you an opportunity with the clever scaling and networking we've got today, and with the ability to run things in a representative environment, but without danger to users. I think you get a much more opportunity for testing. It's nothing you couldn't have done before, but it just lowers that barrier.
You spoke of API gateways. What do you think is the future of it?
Yeah, that's another thing, because an API gateway means a lot of things to a lot of people, right? I guess I mentioned it there because it was seen as the place that you did this, A/B testing, these canary traffic, or it was seen as the place that you would patch over issues that are running. It means a lot of things to a lot of people. I think now it was the only place you could do traffic control. Like, it was the only place you could do smart layer 7 traffic control, and I think a lot of folks used an API gateway for that. Now we have a service mesh. Well, I think you should have a service mesh. You can obviously do all of that alongside every workload, and you can do like back-end stuff. I actually gave a KubeCon talk where I kind of took the progressive delivery thing to the next level, because it's really easy. If your gateway's doing that, then you can canary deploy or A/B test the front-end service, whatever pod is hit first by the user request. But if your services often call each other in these complicated graphs, but like think of one chain through that. If the user hits a gateway and then it goes like this, and then the reply comes back, if the gateway is smart, you can start teeing off traffic like this at the front. But like my KubeCon talk was saying, well, you can do this, and then I want to jump through this new version under test of something that's like 4 services down the chain, and then back onto the main thing. And you can start canarying that in sort of 1%, 5% at a time. So anyway, I digress. Like, I think, what is an API gateway? I think it's a proxy, like a layer 7 proxy, like an Nginx or an HA proxy, with some amount of extra features. Like, why is an API gateway not just a reverse proxy? I think because it's got features like, body schema validation, or but bot blocking or rate limiting, or it's got security features or reservability features or API management features or something like that. And obviously the vendors will sell you the kitchen sink that can do all of them, but actually Nginx or Envoy now, plus plugins, will get you some of those features. So I think the future is a much more open. I think they become a little bit less necessary now. Now everybody's in a cloud and can really easily put a CDN in front of them and a managed WAF in front of themselves. And now they've got a service mesh. Maybe they can become a little bit less relevant. I think we're going to see something a lot more open, where I just take the proxy and then I add only the features that I want. So the Envoy proxy is extensible. You can just it's got a WASM runtime, so you can just add features. No more hacking on the core of Nginx in C, or no more having to use Lua, right, which is obviously awful. Yeah. For plugins, you can now write Rust or TypeScript, and you can compile to WASM, and you can inject into Envoy. So there's now a gateway based on Envoy, called Envoy Gateway, inventively enough. So I can now have an Envoy, which is just that proxy that can do host and path-based routing. And if I decide, I am getting a bit of spam and I need like a bot blocking engine, and I want some global rate limiting, I can add those two things, hopefully from open source projects that I can just compile and inject myself, or maybe I'll go to a vendor and get a little package. But it's no longer a choice between, running my own fleet of Nginx's or spending a fortune with a vendor for a kitchen sink style gateway. So I think it's going to become a much more open, democratized, and the open core model is going to get applied to that business in ways it kind of wasn't before.
I mean, of course, there are a lot of open source tools, like you said, which people can use. But are there any other risks involved that developers should know about, specifically, say, security-wise, or because obviously there's a lot of data that's been shared throughout the...
True, okay, security risk. I mean, this thing is internet-facing, right? By definition, it is the gateway. Mm-hmm. Unless you're doing beyond core, right, or something, unless you want to give every pod a publicly routable IP, like this thing. Even if you're doing zero trust, like this thing is the only thing that's internet-facing. Yeah. So it really should, like every week there's a new O day in Fortinet, right? It's the ultimate example of it's an edge device. It really should have been built to very high security standards. They maybe should have used a fuzzer and used a memory safe language, and it just gets popped every week with a new O day. So anything you're putting on the internet, you need to be a bit careful of. So I guess, if you're evaluating a new one and a move to a new one, you need to be careful, treat it as an edge device, so you would a VPN concentrator. Not that you should have one. Anything you put on the internet. So the new one's based on Envoy. Envoy is a new piece of tech, but it's a CNCF graduated project. I know and Google as well have put a lot of money into code reviews, into fuzzing, into threat modeling, and there's been a lot. Even though it's in a memory unsafe language, obviously buffer overflows aren't the only type of exploit you might have, but there's that other class in there as well. A lot of effort's been put into recognizing the kind of situations where Envoy is going to run and trying to make it secure. The other risk, of course, is it's an API gateway. So like an ESB, just don't let anybody put business logic in it. Yeah. Have the right control. It is extensible and you can write any code and inject it. Just have a culture and process in your organization that says business logic doesn't go here. Code review of anything that's going to go into that, please, because I'm not going to let you start smearing your business logic onto this thing. Thanks.
Yeah, there's going to be a lot of unhappy people when you say that, but it has to be enforced. Can you provide insights into networking considerations for enabling progressive delivery?
I think if we're talking about the kind of progressive delivery that I've been talking about, you just need the ability. So your rollouts or your canaries, because you can. There was always this old, this funny thing I heard of how do I choose that 1% that get my canary release? Are they, because it may well be broken, right? So do I just roll the dice? Does the computer just pick 1% of them, and maybe they're more likely to have a bad time? You could, but you've got all of the headers there. If you've got a layer 7 load balancer, you can look at the headers. So anybody who's running a beta browser or a beta OS is maybe the kind of person that's opting themselves, likes bleeding edge software and is used to some issues, and maybe they've sort of self-selected themselves as the kind of person who might like the newer, shinier version of your site that might be broken. Maybe if your site's broken, they're less likely to blame you because they just think it's their beta browser, right? Or more cynically, you can just go for folks who aren't logged in. feed them the beta, because if it crashes, they're not going to make any. You're not going to make any money from them anyway. Or I would just say, if they're French, just send them whatever. But yeah, so I just think you need some kind of smarter networking gear. So if you can lift that stuff up to layer 7, you can start making those decisions. And as I say, like doing, so you just need that observability and that control. If you've got something at the edge, like an API gateway or even a CDN that can do these kind of things, then that's good to a certain point. But you might also want to start doing progressive rollouts and canary deployments of things deep inside your service graph. In which case, you need those smarts everywhere in the network. Which, to my mind, unless you're a Google with with all that tech or whatever, unless you spend a huge amount of money on ACI, then it's going to be a service mesh for you.
The next question I have is about infrastructure as code. So, are there any recommended practices for incorporating infrastructure as code, with tools such as Terraform into progressive delivery pipelines?
I would hope they don't really touch each other. Mm-hmm. I would hope that I think you should try to keep them orthogonal. I think this is where standardization does come in. We've always had, back in the day when people were trying to build Kubernetes platforms, there was always this discussion of, well, but I actually need, volume's a bad example because you can just go claim a volume now, but like I need a DNS name, right? I need some cloud resource. Like every time I deploy a new service, it might actually need a KMS, all right, say a managed KMS key or something. I should, as an app dev, I should be able to self-serve that. But how do I do it? Does the platform team write loads of code and build an abstraction, which is going to be a lot of work to develop and a lot of work to maintain, and is never going to expose all of the features of the underlying platform? It's always going to limit me a bit. Or do we just let, I knew a platform, a company whose Kubernetes cluster let you, you filled in the blanks that went into a Helm template of, this is my service, so that's the image I want it to run, that's the version. And then you could just give blobs of Terraform or blobs of CDK or whatever it was to say, oh, and by the way, I need a DNS record in a bucket and a KMS key, and you just put in these blobs of Terraform, and they had an operator that would just go and sort of apply them. I think that's pretty bad. If you need infrastructure changes for every new service, or you need infrastructure changes for every new version, you've probably got a bit of an anti-pattern. So I'd hope whatever abstraction you choose, and we talked about this a lot, right? Whatever abstraction you choose, it should not require that. It shouldn't leak that either. I think you should definitely there's arguments not to try to rebuild Heroku, right? Super high level abstraction, but you should definitely hide that. Do you want?
So service meshes, from my understanding, traditional service meshes, you have a sidecar and that gets deployed in every pod in your Kubernetes cluster. But particularly for observability, I've been hearing a lot of buzz about eBPF. Is that going to eat the lunch of traditional service meshes? Like, what's the relationship there between this new technology or this sort of new thing, new tool in our toolbox?
Yeah, I think they're orthogonal. So the question was, eBPF is a cool new thing. Is it going to eat the lunch of a service mesh? Because it sounds like you can do a lot of the same things. I think the first thing to realize is it can't do everything. So you can't parse HTTP in BPF, right? Because it's not Turing complete. So you can't. There used to be a limit on program size. There isn't anymore, I don't think, in the latest kernels. But you can't parse. You're never going to be able to do like all the things that like a Turing complete language in user space can do. But yeah, I think they're complementary. I think it's seen you already. So XDP, so an eBPF shim, a short eBPF program calling XDP, which is the accelerated data path. When most people think eBPF, they think like the fast networking in the kernel. That's actually just a little library, like a little programmable library that's available to BPF. So BPF calling XDP is, getting acceleration is something that a lot of the service meshes already use. Getting that traffic in and out of, so from the host network namespace, like intercepting it and getting it into the tap that Envoy uses and then back out again. All of that stuff can and has been accelerated by BPF. So I think anything it can do, it should. There's definitely been, I don't want to pitch too much, but like Tetrate's management plane that manages Istio will look at the rules that you're feeding into Istio and realize where they're just layer 4. Right, if you're blocking whole networks or you're blocking if you're doing things that can be expressed actually at layer 4, it'll compile it to Kubernetes network policies, which depending on your CNI are often implemented by BPF. So I think, I mean, what you need is a sidecar, I think, right? What you need is what the academics would call a policy enforcement point, right? Alongside your workload, you need something that can apply ACLs to traffic, apply rate limiting policies, parse understand the traffic and produce statistics and logs and spans about it. If that can all be done in kernel space, great. Like for me, a sidecar is a sidecar, whether it's Envoy or whether it's a blob of BPF. I actually don't care. I think the reason it's not all BPF at the moment is that there's some things you just can't do. It may as well, yeah, it absolutely should be a combination of both, and you should probably use BPF where possible because it's quicker, and modulo the difficulty of debugging what the hell's going on in the kernel. But yeah, I think they're complementary. Frankly, a lot of CNI, it gets complicated where your CNI uses BPF and then tries to come up the stack. Or you get CNIs that use BPF and then classic mode Istio that uses IP tables to do the interception. It gets a little bit muddy, but it works. There's no reason they can't all play together.
We have a few minutes left. Does anybody else have any questions from the audience? Or
yeah, I'm very keen to have a discussion with.
If not, then you can always catch Matt Turner after the session is over, or he'll be around. In terms of just wrapping up, do you think there's any trends in terms of platform engineering that the industry should look out for or keep in mind?
I think, and this is a complete recap of what we talked about this morning, I think there's so much tech. You look at the CNCF landscape and it's fractal now, right? There's people, even as a full-time job, you can't keep up with that. Yeah, the tech, enough tech exists, right? Probably too much. There's now a lot of choices. There's still some real innovation. Terraform's great. It did Terraform for years, and I saw crossplay, and then I was like, actually, that's the way you do it. So there's still some real innovation going on, but I think folks are looking at the organizations now, and the people structures are what is a platform team? What should they do? In my opinion, they should. So the SRE model serves Google very well. I don't think it's for most companies. Maybe it doesn't serve Google that well. It seems to work. Empirically, Google's still here, but it's kind of quite an extreme end of the spectrum, from my point of view. And it seems to, I think it suits a company where you've got the ability to invest in that, in terms of people and time and money, where you've got real executive buy-in, where you absolutely have already, you standardize the platform from day one. So an SRE team can practically take over a bunch of services because they look similar enough. Maybe none of this is, maybe I've just read the book and maybe none of this is too true, but the other end of the spectrum is DevOps, where have Node.js developers sling some Terraform if they need a KMS key. I think we're actually learning it should be somewhere in the middle, which is what Team Topologies was saying all along. You should have a platform team with a capital P. That is a force multiplier that enables people. It doesn't do it for them. It provides a platform, provides levers, provides systems they can use, and they need to be able to self-serve. But we're now learning that self-service, obviously we knew it needed to be documented and whatever. We're now learning, I think, that it needs quite strong security controls around it. Take a service mesh. Platform team provides a service mesh, installs it, operates it, makes sure it's available, and says, there you go, everybody, please use it. Well, you can do traffic control, you can do things that app devs want to do, like traffic control for A/B testing, and you can do things security folks want to do, like ACLs. You can't just give everybody access to the Git repo where they put the YAMLs, because you actually don't want just to keep your controls tight. You don't want anybody to be able to fiddle with those security rules. I think you actually want the security folks, and only the security folks, to have access. Although it's the same sandpit, the same level of abstraction, there's some bits that are consumed by some persona and some bits that are consumed by others. So I think we're learning to put audit into config changes. We're learning to put kind of quite hard multi-tenancy into these things. But yeah, I think we're learning about organizational structures, and the tech has almost settled down, maybe. There's definitely some sort of good, maybe it's not clear yet, maybe there's no best practices, but there's definitely some very good practices around. You need some IAC, you need Kubernetes. I mean, that one, right? I think you need a service mesh. I think Istio won in that space. You definitely need an orchestrator. Kubernetes definitely won in that space. So there's some kind of good practices. So you can definitely get this. You can definitely get started. And then I think folks are looking, I'm excited about how we we'll build organizations around it and how folks interact and how organizations are structured. And yeah, and I think SRE gives us a shining light in one direction that might work for you and is a North Star. Probably doesn't work for most people. I think DevOps, it was always meant to be a culture, right?
Yeah.
It gives us an example of, hey, you should talk to each other, you should work together, you should collaborate. But I don't think having, Node.js developers write Terraform is the right way. I think a platform team in the team topology sense, and actually something Eli said to me this morning that I hadn't thought of before, was you also need what team topologists would call enabling teams, right, to actually go and help folks use it. So it's people you can actually go and embed into a cross-functional, multifunctional team. You maybe don't need a full-time equivalent platform person. You maybe don't need an engagement from a platform person forever, but you need it as and when you need it. So if there's a set of folks essentially doing internal dev advocacy for that platform, internal training and knowledge sharing, then yeah, I think that's what we're learning, and that's quite exciting.
The only thing I have in mind is, does that make the organizational structure a little more complicated with a lot more layers and having a lot more people pointing out like issues and stuff in each other's work, or does it make it easier, like you said, knowledge sharing, which kind of adds to it? But I guess that's a matter of trying things out, and like you said, it's changing.
I think it should make it easier. I think if it doesn't make it easier, you need to have a word with yourself. I don't think you should have more layers. I think you should have more communication. Yeah. Definitely, by getting the right folks with the right knowledge, able to become experts and build that knowledge, not trying to get somebody to do everything, getting them, I kind of hate the phrase, but like a T-shaped engineer, right? My depth of knowledge might be in Python or Node or this particular domain, but I know enough about AI, generative machine learning to know where it can maybe help me and where I might want to go talk to one of those complex subsystem teams, be like, hey, please bring this in. And I know enough in my T-shaped arm, right? I know enough about infrastructure to know what to touch, know what not to touch, know who to ask for help. So I think you should definitely add more communication, if not layers. And you've got to experiment. I say, it's going to depend on your organizational context. I've been saying all these roles as if they're individual people. They're only going to be, one or more people if your organization's big enough. In a startup, there's going to be a lot of those. They're all hats, and they're going to be all worn by basically one person in a startup that's small enough. Yeah. But yeah, I think Team Topology is a great book. And it talks about the reverse Conway maneuver, right? It's like, how reliant are we on our infrastructure? Like, is this a company that's trying to run really tight margins, so it needs a really effective, automated infrastructure that's very low cost? Or have we got a bit of VC money to burn? Do we just want to move fast? What are you trying to achieve? What are your constraints? What would the ideal organization look like that would produce that? And that's your reverse Conway maneuver, and then go put that together. It's super easy to say, but there's a reason I'm an engineer, not a VP of engineering. Like it's very hard to do, I imagine. But yeah, experiment, be honest with yourself, feedback.
Like you said, communication, not just internally, but also, I guess, with other companies, and kind of have a collaborative approach to what is the best way forward.
Well, that's what conferences like this are really great for, right? Is to go and learn from other folks' experience. But you can't overfit to it, like just because there's another actually very interesting thing that Eli said this morning, right, which is that a lot of what you hear at conferences is survivor bias. No, honestly, but if it's on stage, it worked for them, but that doesn't mean there weren't 99 other cases in which it failed. So yeah, and just because a company with a cool startup or a big tech with a cool name is doing it, doesn't mean it's appropriate for you. So don't try to overfit to heroes. On the other hand, things like Team Topologies and the SRE handbook are incredible resources that everybody should read and sort of critically consume. Yeah,
those are good resources to keep in mind. On that note, I think we should wrap up. And if anybody has any questions, feel free to get in touch with Matt. He's going to be around. Have a lovely rest of the evening. Thank you so much, Matt, for all the questions. Thanks. And thank you very much.
Thanks, everyone.